This is the IAM Principals room, an overview of the different types of actors in IAM. I notice here, so this little hard hat looking icon, just so you know, if you're new to AWS and you start learning how to read AWS architecture diagrams, this is usually used to indicate an IAM role. So it's very appropriate for the header of this room. For task one, Introduction to IAM Principles, IAM identities, sometimes referred to as IAM principals, provide access to an AWS account and its resources. I'm curious what this links to. Let's see. Nice. So this is the AWS IAM documentation, and looks like this page is about IAM identities. And this header is identifying three types of IAM identities: users, user groups, and roles. We learned about all three of these in that room we were just in. So go back and watch that if you're curious to learn more. Now, back to TryHackMe. So it's talking about how principals or the identities typically provide for authentication or validate authentication was performed before you can do anything. Principals are a core concept for resource policies that are attached to resources, such as an S3 bucket is an example of an AWS resource, which is a storage resource, and define who is allowed to act on the resource. So IAM principals are the who typically. This room will explain the multiple types of IAM principles and their significance for attack and defense tactics. All right. No need to enter an answer. Let's hit completed. Okay. Whoop, whoop. We're correct. We didn't have to do anything except read, but reading is very important. Next, we're going to access the environment. Awesome. So I bet we are about to log into a Sandbox AWS account for the first time. And this learning path does come with Sandbox AWS environments that you actually get to go in and play in. But let me not get ahead of myself. Let's see what this actually says. Okay. Where needed, generate the environment required for the room. The Generate Environment button will appear if the room contains an environment that needs to be generated. Any issues with the environment, select the Reset Environment button. Oh, that's very cool. And we can read this article, I think, to learn some more information about how their AWS environments work, which I will definitely be doing because I'm very curious about that. To view the credentials required for the environment, we have a Credentials tab. You can use these credentials to access the environment in various ways. More information can be found here. Okay, so there's a couple little parts of TryHackMe documentation I'm going to dive into. But before we do that, let's make sure we know how to actually do this and generate the environment. So it looks like we scroll up, we hit Cloud Details right here. This is the Generate Environment button. I'm very eager to see how long the environment generation takes. I don't know how we count down or anything like that. Let's see what happens when I hit Cloud Details again. So we are in a generating state. And I wonder if we have credentials already. Okay, so we do have credentials, but looks like we are still generating. So let's see what happens if I try to log in. Nice. And when our environment is actually ready, we get this little pop-up, your environment is now ready. Then when we do see that, we can come back over to environment state. Environment state is active and we have access to an environment for the following rooms. So it looks like this is going to be a common environment we're going to use for a bunch of these different IAM rooms. So that's exciting. Using these credentials from this credentials tab here, I went ahead and logged into the console. So now I am here in the AWS console for this TryHackMe environment for the IAM rooms. I'm very interested to learn a little bit more about how they organize this and how they manage that reset functionality they talked about, which is really cool. So if we mess this up, we can press that reset button 3 times a day, up to 3 times a day, and get our environment fresh and get our environment back to stage one for us, which is very cool. And I am curious to see what kind of permissions our user has in this environment. So I'm going to go right before I even do anything in this room, I'm going to go right over to IAM. This is the IAM dashboard in this AWS account. I don't know if this is the same AWS account that I will use for the entirety of the learning path or if I will get new accounts. So I'll be able to tell that from the account number as we go on. But right now I'm interested to see how it all works. So it looks like we've got 2 users in this account. We've got this user, which is the user I logged into the console with. And then we've got this TryHackMe IAM user. Let's see what kind of permissions this user has. Okay, so we've got Cloud Shell full access. Cloud Shell we could use to run commands if we wanted. We have the needed permissions for the module. So this might be an example of least privilege here, which is an inline policy with only a few permissions. And then we've got the read-only access policy, which is an AWS managed policy that lets us basically see a bunch of things in the account, but not make changes, just read-only. Okay, and we are part of one group, the IAM module group. Let's see what the other user has going on. So I bet this TryHackMe IAM user is something TryHackMe uses to manage and administrate these accounts because this user has admin admin access, invalid action. Okay. And then this policy is called what admin giveth, inline policy taketh away. What admin giveth, inline policy taketh away. So I bet that's part of an activity coming up. And they are also in the TryHackMe IAM group. Let's see what the TryHackMe IAM group has attached. So the TryHackMe IAM group has the administrator access policy attached, which means that's like God mode in AWS. And that means both of those users we saw are part of this group. And then same thing, this group has these same permission policies. So that would indicate, if we click on this user, that these permissions are all being derived from the group. Yep, they're attached via the TryHackMe IAM group. And then one more thing, and then I promise we'll go back and actually do the room. So this user that I get to log in as is part of a different IAM module group. Okay, so they're demonstrating here a best practice, which is rather than attaching policies directly to users, you want to put users in groups and then attach policies to groups, which is a better user management practice. Okay, now that I've done a little bit of exploration in here, I do also want to just go see if I can figure out if we are part of an organization. So we can navigate to this AWS organizations console and we can see we are part of an organization and the management account for the organization we are part of. This is the account ID number. This is the owner email address for the account that manages the organization. I'm going to click this leave the organization button, but I predict I'm going to get an access denied error because I don't have any policy, because I don't have any permission policy that gives me permission to leave the organization. So let's see what happens if I do that. Yeah, see, I don't have permission to take that action. I do not have an IAM policy attached to my user that gives me permission for the leave organization action, whatever it's actually called. All right, so that was just like a little bit of exploration. Now I'm going to go back to TryHackMe and actually walk through the steps in the room. So thank you for indulging me on that tangent. Okay, so back to the actual room, we can scroll down. We figured out how to access the environment. So we can hit completed here. We're into the account. I'm going to close that. And next, we're going to focus on task 3, which is about IAM users. IAM users are the most basic form of an IAM principal. They represent a person or an application. Typically, I'm sure we're going to read about this. Typically, you would want to use an IAM role for an application. Just keep that in mind. IAM users exist in a single AWS account, and AWS acts as both the authentication and identity store for IAM users. Take a look at the users that exist in your TryHackMe account via this console link. Okay, so I jumped the gun a little bit. That's what I was doing a minute ago, but we can come to IAM. They gave us a direct link, and we can see we have 2 users. This user, this number user who is me that I'm logged in as, and then the TryHackMe IAM user. IAM users can have both a login profile and up to 2 access keys. The login profile is a password that grants users access to the AWS Web Console. Access keys are AWS generated and consist of a key ID and secret. All right, and this is giving us some screenshots. So this is an example of access keys. Let's see if my user has any access keys. So we could come here to security credentials, and my user does have an access key. And it was created 17 days ago and it has never been used. So I'm curious to see what we're going to end up doing with that. In my actual AWS usage, and I have some other videos about this on my channel, I do not use access keys. I really, really try not to use them. I use Identity Center and single sign-on instead, and just always use temporary credentials. These long-term access keys, you really want to avoid creating them whenever possible. Okay, and then the AWS CLI, we can also use to see these users. So I'm going to authenticate with the CLI really quick. I already have it installed locally. But if you didn't have the AWS CLI installed locally, you could use Cloud Shell in the AWS console. And that's why we saw that permission policy attached earlier too. So there's Cloud Shell, which is a browser-based CLI that's already configured with the AWS CLI. But I prefer to use my local terminal. So let me get configured here. We're using the credentials for this TryHackMe sandbox. One moment. This is going to be a little bit jumpy because I do not want to show any of my credentials on the screen because I haven't figured out yet if these are ephemeral accounts or if this is an account I'll be using over time. And also, it's just gross to see credentials naked on the screen. But if you wanted to configure your local CLI to use these sandbox credentials and you already have the AWS CLI set up, just as a reminder, you can run this AWS configure command and follow these prompts. Then as you're following those prompts for the AWS configure command, you can use these access key ID and secret access key to configure the CLI. Or if you already really know your stuff with the AWS CLI, you can do what I'm actually going to do, and you can add a profile to the CLI so that you don't have to mess with your other profiles you might have configured. Then, fun fact, What happens when you run that AWS configure command is that the AWS CLI creates this credentials file. So let's see, I can run cat AWS slash, I think it's will be credentials. Here's the credentials file that just got created when I ran that configure command. Now, because I use Identity Center and SSO, I don't use long-term access keys. I don't have any actual profiles for my account here. But if I did, what I could do would be edit this file and I could rename this profile to something like TryHackMe. Then it could coexist with other profiles I might have in place there. Anyway, that's probably overkill for what a lot of you are doing, but I'm going to do that too. But I want to be able to run commands locally. Cloud Shell would make it so you don't have to do any of this. Anyway, let's see if I can run this example command. So I can do AWS IAM list users, and because I configured a profile, I need to do the try hack me profile, and I can see the same thing as what's described in this screenshot. So there's our 2 users. So those are our same 2 users we just saw in the AWS console. Let's see. I'm so sorry. I've gone on so many tangents, but now we're getting into like the really fun nerd out stuff. IAM users are the most common way that AWS accounts are compromised, usually due to careless handling of the IAM access keys generated. See, that's why I just said I really try not to use these access keys. These are a big problem. The access keys are often committed to GitHub, stored in config files insecurely, or shared via other insecure means. So there are 2 AWS users in our account. The one you're using is the 12-digit account ID. What is the name of the other user? Okay, so we saw that in the console. So remember, you could come to IAM and then users, and we could get it here. Or we also have it as the output from this command we just run. So we're going to do the username, and that's our flag. Let's see. All right, awesome. Now on to IAM roles. For task 4, we're tackling IAM roles. An IAM role is an AWS principal intended to be assumed by a person, service, or resource. For example, an EC2 instance might require permissions to an S3 bucket where your objects are stored. With IAM, an EC2 instance is permitted to assume a specific role that has access to S3. So oftentimes IAM roles are used to give one service permission to do something with another AWS service. With AWS IAM, an EC2 instance is permitted to assume a specific role that has access to S3. Roles are also used when larger organizations use an external identity provider to access AWS. So an example of that might be like an identity provider could be like Google. So maybe you somehow want to let users use their identity with Google to access services in AWS. The way that actually happens, and I imagine we might get further into it, is that these users would be able to use their Google identity to gain access to assume an IAM role that has permissions to whatever they need to do in AWS. Roles are also required when AWS itself wants to take action on your account. So let's take a look at the roles in our TryHackMe account via this AWS console link. It looks like we've got 10 roles here. We've got, we've got this stack sets exec role. So, okay, nerd out moment. That would indicate that they use CloudFormation to deploy, which makes a lot of sense. That's what a lot of these learning environments do. So let's see what we can see over here real quick. Yes, okay, so these are our CloudFormation stacks that they use to deploy the infrastructure in these environments. Now, what else do we have? We have a TryHackMe budget Lambda execution role, a TryHackMe invoke event, TryHackMe IAM role. I digress. Let's see what we're supposed to be doing. IAM roles have what is known as an assume role trust policy. This trust policy specifies what principals are permitted to assume a role. Click on any of the roles in your account to see the trust policy. All right, so let's look at this one, for example. So this trust policy allows the AWS event service to assume this role. And it looks like what it's allowed to do is put events to a certain event bus. Okay, interesting. All accounts event bus. All right, so in this screenshot, we can see the role can be assumed via the effect allow by the AWS service support.amazonaws.com. So this is a different role. They're using that as an example. Let's run this command now. Oh, okay. So this is because I forgot to use my profile flag earlier. Now I'm making things more complicated than they need to be. All right, so now we can see these are the same roles we saw in the console, and we can see the assume role policy document for each of these roles that determines what principal is allowed to assume the role. We can see the description, we can see max session duration. So that would be when an entity assumes the role, how long they can use that role for before they would need to create a new session, all sorts of things. Okay. The IAM service API call assume role is the operation that leverages this trust policy. We will discuss how that is used and how you can leverage that in an attack scenario in the room discussing AWS credentials. More foreshadowing. And here's our question. There are several roles in your account. What is the trusted entity for the organization account access role? All right, so I used the CLI output last time. Maybe I'll use the console this time. So let's go back to roles, and we want the organization account access role. And what was the question? I already forgot. What is the trusted entity? Okay, so we need to go to the trust policy. This is the trusted entity that is allowed to assume this role. The principal that's allowed to assume the role is an AWS-based principal. And this is the RN for, I believe, an IAM user. So it looks like to me the root user of this other AWS account is allowed to assume this role. All right, let's see if that's correct. Okay, brilliant. Task 5 is about root user and the AWS account. The root user is a special form of IAM principal meant to represent the account's owner. Root users have full privileges in the AWS account. So if I can compromise your account root user, I can do absolutely anything. That is very bad. Now, if the account is part of an AWS organization, the root user in the account is subject to any service control policies that we're going to learn about later. So if the account is in an organization, the root user is a little bit different, but still. The username for the root user in AWS is always the email address used to create the account. We learned a little bit about this earlier. You will rarely encounter the root user in day-to-day AWS development. That is if you are doing it correctly. If you're implementing the security best practice, you might be surprised how often you actually would encounter the root user being used. As a defender, you want to ensure the root mailboxes for all your AWS accounts are monitored. Right, exactly. Because not only does AWS send alerts to that root user email, but also think about it. If I can get access to that email account, that is the email for the root user of an AWS account, if I can compromise the email, I can pretty easily probably compromise the root user for the AWS account. So you really want to make sure, especially, if you're learning AWS and you're thinking about maybe practice AWS accounts you've set up or something like that, how secure is the email account that you used when you created your AWS account? Does it have multi-factor authentication? How complex is the password? How easy would it be for an attacker to compromise that email and then make a jump to the AWS account root user? Spoiler. Okay. So again, so it's saying the same thing here. As an attacker, if you have access to the email box for the root user, you can potentially reset the password and take control of the AWS account. And looks like we're going to practice doing that in a future room too. Fun fact, before 2017, AWS accounts and Amazon retail accounts that shared the same email address were linked. This created what's known as the underwear problem, where a startup's AWS account had the same account as the founder was using to buy their underwear on Amazon. That's a very vivid example. But this is important because full access to the account could be shared if an Amazon retail account was shared. When they say Amazon retail, they mean like Amazon.com where you go shopping. Now that's just kind of like an anecdote, but the important thing, once again, we're getting reminded, AWS recommends do not use the root user account for day-to-day activities. You should always use an IAM user or role unless you are doing one of those few operations only the root user can do. It is not possible as an IAM user to identify the root email address of the account you're in. However, if the AWS account is a member of the AWS organization, you can discover the email address of the organization's master account. And I don't know if you remember, but we actually just did this a minute ago when my nosy ass wanted to know if this account is part of an organization, because we went to the organizations console and we could see the organization we're part of. And one of the organization details here is the management account email address. So we can see this is the root email for the management account of this organization. Very interesting. And I bet I should have guessed that this is going to be the flag for this question. All right. So, and looks like we can get it from the CLI as well. So here is that master account email for the TryHackMe account. Yep. Whoop, whoop. That cracks me up. Whoop, whoop. We got that right. Looks like task 6 is about IAM groups. IAM groups are collections of IAM users. Groups are useful in that you can apply policies to the group and users in the group inherit those permissions. We saw that in the console just a moment ago, poking around. Only granting permissions via IAM groups is considered a best practice in many circles. So we saw the groups before, but just as a reminder, we can go see them again. We can go see them again. Oh, Interesting. They have some sort of perhaps logic problem in the group name here. TryHackMe user group. Let's just try and go there by hand. So we can go to user groups, and so we can go to user groups, and here that is here. So now I'm curious. TryHackMe user group. Yeah. So that's why that didn't work. So they must have built that redirect URL when the group was called TryHackMe user group. Um, but now I imagine maybe we're trying to go to the TryHackMe IAM group. Anyway, throughout your TryHackMe AWS journey, your IAM user will be granted the proper permissions for the room you're using. This will be done by adding your IAM user to an IAM group that matches the room you're in. Oh, okay. Very clever. So we can also see our groups from the CLI with, looks like, AWS IAM list groups profile. TryHackMe. Nice. So we can see those two groups there as well. Technically, IAM groups are not principals. Oh, okay. I might have misspoke on that earlier because they're only a grouping of privileges, not the actual authenticated entity. So the user would be the actual authenticated entity inheriting permissions from the group. What is the name of the IAM group your IAM user is currently a member of? I wonder if I can get this from the list users command. Let's see. Okay, I cannot. Okay, so to find this, we can go back to the IAM console. We can find our user again, and we can navigate to groups here. Well, we can see a couple ways. So we can see our permission policies we have attached to us. We can see they are attached via the group that we're part of, which is this IAM module group. Or we can go to groups here, and we can see we are part of the IAM module group. So let's copy that name. Whoop, whoop. All right, another correct answer. Task 7 is about AWS services. From an API and IAM perspective, AWS has several services. These services do not always align with how they appear in the AWS console or the marketing name used. For example, AWS VPC, the software-defined network construct, is part of the EC2 namespace. Has thrown me off before, so this is cool that they're calling this out. The call to create a VPC is called EC2 create VPC and not VPC create VPC. Amazon CloudWatch is a combination of several services, including CloudWatch events, metrics, and logs. Because of the AWS two-pizza team organizational structure, there is not consistency between services around how API calls are named. Some services use get for describing resources, while others use describe. So that's why they were telling us that lore before about the two-pizza teams, is to set us up to understand this a little bit better about the API calls. The AWS Python SDK documentation is an excellent source for understanding the AWS API service calls. I don't even have to click this link because the Bodo 3 documentation and me are best friends. We spend a lot of time together, and it is very illuminating. I do agree. From the perspective of IAM principals, AWS services can act on resources in your account. Often, a service like Lambda or EC2 will assume a role for your application to access resources. In the context, will assume a role for your application to access resources. That's that example we were talking about before, where maybe something running on your EC2 virtual machine needs to read an object in your S3 bucket. They would use an IAM role to do that. In the context of AWS IAM, services are always in the form of .amazon.aws.com. And AWS services are often represented in the assume role trust policies of IAM roles, which we saw that before poking around in the console too, where we saw, I believe it was the events service in the assume role trust policy. All right, so what AWS service is trusted to assume the role AWS service role for CloudFormation StackSets org member? Well, my guess, just based on the role name, would be CloudFormation, the CloudFormation service. Let's copy the role name and let's navigate. Oh, we're already in IAM. Perfect. So let's navigate to roles. And let's find that role name. Remember, role names are unique in the account, so there will only be one role with this name. And the question was, what AWS service is trusted to assume the role? So let's look at the trust policy. And the service is CloudFormation. So we've got member.org StackSets CloudFormation. All right, let's copy that. I assume it wants the whole thing. Submit. All right, so the CloudFormation service is allowed to assume that role. Let's see what task 8, everyone, is about. There is a unique principal, the asterisk, the wild card, which represents everyone. Depending on the AWS service, the everyone principle could mean anyone on the internet or any AWS customer. The everyone principle is how resources are made public, either on purpose or by accident. So that's why it's very important to understand how this works, because it does happen by accident sometimes. The everyone principle is typically used in AWS resource policies, which we are going to discuss in a future room. Just agree you're going to do your best not to win a bucket negligence award. That's a joke. But that's because a lot of times what you'll see is these wildcards in S3 bucket policies, and a misplaced wildcard in the S3 bucket policy makes your S3 bucket public to anyone on the whole internet, can read things in your bucket or download them. And sometimes, as is alluded to here, you might want to make a bucket public on purpose. I imagine we might explore that use case further. But when you have that wildcard in there by accident, bucket negligence does indeed occur. So we're going to avoid that. We're going to hit completed. I like this sense of humor. Task 9 is called Federated Identities. Most companies in AWS have adopted a multi-account strategy. AWS accounts are created according to application, team, or environment. So examples of environment would be dev, development, QA, so that's like a testing environment, and then production. Each employee having multiple IAM users becomes an untenable situation. True that, preach. Most enterprises leverage a centralized identity store like Active Directory, for example, and SAML authentication services, with a couple examples here, or OpenID, to grant employees access to assume a specific IAM role in specific accounts they are authorized to access. We were touching on that a little bit before with the Google example. So this is, rather than having an IAM user in the account that you would use, you would have your employees use an identity from some sort of external identity store to assume a role in the AWS account to do only what they need to do in that AWS account. An identity provider is created with a SAML metadata document. Once authenticated by the corporate identity system, a SAML assertion document is passed to AWS, and the assertion lists the accounts and roles that that user is permitted to assume. So here's a diagram talking a little bit about how it works. So this is the external identity provider. The user logs into a portal. The user authenticates against that external identity store. In this example, it's Active Directory, it looks like. Then the browser interface gets a response with the SAML assertion. The SAML assertion then gets passed to AWS to sign in with the security token service. That's how they assume the IAM role, which has the IAM policy attached to it that has the permissions to do things in AWS. STS sends back temporary credentials to that same browser interface, and then the user is redirected to the AWS Management Console. And you can't see it in this picture, but up here in the right, it will say the role that this user has assumed. So they're not logged into AWS as a user like we are in the sandbox right now. They've assumed a temporary role using temporary credentials. And this is a very good architecture pattern and a very common architecture pattern. It's really good to understand this. Then it says, with federated access, the authentication system provides multi-factor authentication. Federated access just means like using one identity provider to govern access to more than one like domain or application resource, etc. Federated access requires that one or more IAM roles trust the SAML identity provider created in your account. If you look at the TryHackMe IAM role in your account, and I close these other windows, let's follow this direct link. So we come here. This is the trust policy. We've got the action STS assume role with SAML is allowed. And we've got the principal, which is the SAML provider here, TryHackMe IAM SAML provider. Let's see what the question is. What is the name of the sample SAML identity provider in the account? So the name is probably this last part of the ARN here. And notice the SAML provider does have its own ARN. So let's see if that is correct. Okay, awesome. And oh god, it became midnight again. My streak increased to 4. So I'm going to do this last task and then I'm going to go to bed. Now that we have defined the various actors in the AWS IAM space, the next room, IAM permissions, will go into how those actors are authorized to operate on cloud resources as we dive into the structure of an IAM policy statement. Sounds very fun. I will be looking forward to doing that hopefully tomorrow. And for now, we have finished the IAM principles room, hit complete, and awesome. So that is 4 rooms done in the attacking and defending AWS path. Hopefully, I will see you in the next room.